Even if you could travel at close to the speed of light, the nearest stars would still be half a decade in your future. And don't even think about trying to drive faster than the speed limit.
One of the problems with relativity that Einstein found was that material objects, people, robotic spacecraft, whatever, can't travel at the speed of light. Basically only massless particles like photons, like light, can travel that fast. The interesting kick here is that space-time itself is allowed to move faster than the speed of light. You and me, embedded in space-time, are still trapped by the speed of light time limit. But this rubber sheet that space-time is able to move very fast.
As every science fiction fan knows, the loophole in the cosmic law book is to follow Alice down the rabbit hole.
A wormhole basically operates by boring a hole through time-space to connect two very distant spots. The idea of how a wormhole works is a little bit counterintuitive. But one example that we often use is to take just a sheet of paper and bend it into sort of a U shape, where now if you're traveling the long way around through normal space, it takes many years to get, say, from Earth to Alpha Centauri or any other star. The wormhole basically takes a shortcut, and in fact in the extreme limit you're warping space with the wormhole so strongly that the 2 points basically touch. It would almost be like opening a door on Earth and walking through the doorway, and now you're in Alpha Centauri. Now there are theoretical wormholes that scientists have derived that do everything a good science fiction wormhole does. So maybe they can be produced by some very advanced technology.
And what about that other advanced technology, the warp drive?
The trick is basically to have a little bubble of space-time that you're sitting in, and you basically treat space in front of you and behind you like a rubber sheet. In front of you, you compress it. Behind you, you expand it. So that when you get where you're going, you just let everything snap back to normal, and now you have in effect moved much faster than the speed of light over a very long distance. Now from a practical point of view, how do we go about building these things? That, as they say, is an engineering problem, a very large one. And yet it only took 40 years, 45 years to go from E equals mc squared to a working atomic reactor and atomic bomb. So very often, if there is a theoretical and experimental example of something, even though it's very strange physics, that usually means somewhere along the way someone will develop a technology to exploit it.
And maybe that someone could be you. If you're feeling the pull of these wormholes of information, there's a universe of useful metadata available on the other side. Just pick, click, and engage.